18 comets, all different orbits, all pointing back to the same spot in space. I traced each orbit backward through centuries of NASA orbital data. They do not scatter randomly, they cluster, they converge, they point to one event. Something exploded near Earth's orbit, and the debris has been coming back on schedule ever since. This is what the investigation uncovered. The investigation begins with one comet. In 1826, a German astronomer named Wilhelm von Biela tracked a dim, unremarkable object orbiting the Sun every 6.5 years. He calculated its full orbit, a short-period comet, predictable and well documented. Then it split in two, then it vanished entirely, and when Earth passed through the spot where it used to be, 15,000 meteors per hour rained down from the sky. Cities burned, but that was just the beginning. Stay with me, because what happened next with Biela is just the first thread in a much larger pattern. The official record shows Comet Biela was first spotted by a French astronomer named Jacques Libax-Montaigne on March 8, 1772. 33 years later, Jean-Louis Pons rediscovered it, passing within 6 million kilometers of Earth. Close. Very close. If the comet returns every 6.5 years, it should have been visible 5 times between 1772 and 1805, and 3 more times between 1805 and 1826. 8 passes. Nobody saw it. The standard explanation is that Earth was on the other side of the Sun each time, which is plausible but worth questioning. But there is one date that stands out. November 1812. According to NASA's JPL Horizons orbital calculator, the same tool used by professional astronomers and mission planners worldwide, Comet Biela crossed Earth's orbit that month, not near it, through it, and just 9 days later, Earth passed through that exact same point in space. 9 days. That is all that separated us from a direct hit. But even a near miss is not harmless, because Biela was not a solid rock. Based on spectral analysis consistent with established comet science, it was a loose, crumbling mass of clay, sand, and trapped gases. It was already shedding a cloud of debris behind it. Now, here is where the investigation takes a turn you probably did not expect. Consider what was happening on Earth in November 1812. Moscow was burning, the entire city, and nobody can agree on who started the fire. Was it Napoleon, Kutuzov, retreating Russian troops? The historical debate remains unresolved to this day. Eyewitness accounts describe something unusual about the Moscow fire. Fires erupted in multiple districts simultaneously, not spreading from a single point, but appearing as if ignited from above. French officers in Napoleon's army reported incandescent fragments falling from the darkened sky. The fire chief of Chicago described a strikingly similar situation 60 years later. Quote, "Alarm signals came from every part of the city simultaneously. It was as if hundreds of arsonists were setting fires in different places at the same moment." He was describing the Great Chicago Fire of 1871, which occurred during a documented Biela meteor shower. Here's a documented record. In 1871 and 1872, Earth passed through the debris field left by the now disintegrated comet Biela, 3,000 meteors per hour. In 1885, 15,000 per hour. In 1885, 15,000 per hour. In 1892, 6,000. This is established observational astronomy. These meteor counts were recorded at multiple observatories. But Biela is just one comet. What happens when you look at all 18? Biela completes its orbit every 6.5 years, so the investigation requires looking further back, much further. Using NASA's JPL Horizon system, I calculated Biela's position backward through time. In 1812, it crossed Earth's path within 9 days. Go back further to November 28, 1699. That year, Comet Biela appears to have passed within 1.5 million kilometers of Earth. For context, the Moon is 384,000 kilometers away. this object passed at roughly 4 times the lunar distance, while shedding debris the entire way. 1.5 million kilometers. For context, the Moon is 384,000 kilometers away. This object passed at roughly 4 times the lunar distance, while actively shedding debris, gas, and particulate matter. Something that close, that unstable, would have left a mark on Earth's atmosphere at minimum. Something significant seems to have happened around that time. In 1699, Russia abandoned its existing calendar, one that had been in use for centuries. Starting January 1st, 1700, Peter the Great, a completely new system of counting years. Calendar resets historically correlate with major disruptions, though the exact cause here remains debated. Calendar resets are not trivial acts. Historically, they correlate with events so significant that societies feel compelled to mark a new beginning. The question of what specifically prompted Peter's decree remains a subject of scholarly debate, but the timing is worth noting. Now, this is where the data gets genuinely surprising. Let me show you the 3 critical dates. 3 dates form the backbone of this investigation. 1699, the closest approach, a possible impact event. 1812, the 9-day near miss, Moscow burns. And using the same orbital math, the next critical alignment after 1812 comes in 1918. 1918, the year of the Spanish flu, the deadliest pandemic in modern history, 50 to 100 million dead in 18 months, and it started in a way that epidemiologists have struggled to fully explain. The Spanish flu did not spread like a typical infectious disease. It appeared simultaneously in places with no documented contact between them, military bases, remote islands, ships at sea. The pattern of spread challenged the standard models of person-to-person transmission. This puzzled one of the 20th century's most accomplished astrophysicists, and his explanation might change how you think about pandemics. This anomaly drew the attention of Sir Fred Hoyle, Fellow of the Royal Society, Plumian Professor of Astronomy at Cambridge University, and the man who first explained how chemical elements form inside stars. Hoyle coined the term Big Bang, received the Royal Medal and the Crawford Prize, essentially astronomy's equivalent of the Nobel. He was not a fringe thinker. He was one of the most decorated scientists of the 20th century. Hoyle, along with his colleague Chandrasekhar Massinger, a professor of applied mathematics at Cardiff University, developed the panspermia hypothesis. Their peer-reviewed research proposed that when Earth passes through cometary debris, fine particulate matter enters the upper atmosphere. If that matter contains organic compounds or dormant microorganisms, it descends globally and simultaneously, not from person to person, from sky to ground. Hoyle specifically pointed to the 1918 Spanish flu as his prime example. The outbreak started in late 1917 and peaked through 1918, precisely when debris from Biela and several other comets intersected Earth's orbital path. His hypothesis was controversial. Many scientists disagreed, but it was never conclusively disproven. But Biela was not alone in 1918. Remember, this investigation tracked 18 comets. Let me show you the full picture. Here is the methodology. Using NASA's JPL Horizon system, the same ephemeris database used to navigate the Voyager missions, plan Mars landings, and track near-Earth asteroids, I selected 18 comets whose perihelion falls within 1 astronomical unit of Earth's orbit. For each one, I calculated every perihelion passage backward through the centuries. The results are striking. In 54, 6 of the 18 comets passed through Earth's orbital zone, including Biela and Comet 8P Tuttle, nearly simultaneously. The probability of 6 unrelated comets clustering like this is extremely low, but the data suggests they may not be unrelated at all. And the clusters keep growing. Watch the numbers. Between 16O and 16N, 7 of the 18 comets returned to Earth's vicinity. 1724 and 1725, 8 comets passed near Earth within a 2-year window. and then the peak between 1815 and 1812 of the 18 comets passed through Earth's zone, 12 out of 18 in 3 years. 1816 is known in history books as the year without a summer. Crops failed across Europe and North America. Snow fell in June. The standard explanation is the eruption of Mount Tambora in Indonesia. But volcanoes do not explain why 12 comets arrived at Earth's doorstep at exactly the same time. That is a separate question worth investigating. The 1724 cluster deserves attention. 8 of 18 comets passed near Earth within a 2-year window. Peter the Great dies under disputed circumstances shortly after. Within a decade, Russian military expeditions report villages buried under layers of sand and clay, descriptions that sound less like typical weathering and more like material deposited from above. Let me walk through the individual comets, because the specifics matter. Comet 3D Biela, November 1812, crossed Earth's orbit 9 days ahead of us. Comet 8P Tuttle, May 1817, perihelion, right on Earth's trajectory. Comet 13P Orbers, March 1817, passed through the orbit of Mars. Comet 26P Greek Skellerup, March 1817, close to Earth's path. 3 comets in a single month. Comet 34D Gale, May 1817. Comet 41P Tuttle Giacobini Kazak, September 1817. Comet 46P Wirtanen, 5 days later. Comet 103P Hartley, November 1816, nearly touched Earth's orbit. Comet 104P Kowal, September 1815. And 41.5 Wilson Harrington lingered near Earth's path for 6 weeks in 1880. 14 of 18 comets in a 3-year window, all crossing near Earth's orbit. The math suggests this is not coincidence. This looks like a debris field returning to its point of origin, like a fountain where everything that goes up eventually comes back down, on schedule. But here is the detail that really caught my attention: the orbital angles. Here is a critical insight grounded in standard orbital mechanics. Every one of these comets has what astronomers call a polar or near-polar orbit, meaning they travel high above and below the ecliptic, the flat plane where the planets orbit. This is significant because, as any celestial mechanics textbook will confirm, this is the signature of violent ejection, not gradual capture from the outer solar system. Objects from the Oort Cloud or Kuiper belt arrive on relatively flat trajectories because they formed within the same protoplanetary disk as the planets. But an explosion, a violent disruption near Earth's orbit, would send fragments in every direction, up, down, sideways. And that pattern is consistent with what these 18 orbits show. And there is one more commonality. Their orbits all cross Earth's path at the same point in Earth's annual journey, between October and February, the same seasonal window. Every time, this constrains when the original event would have occurred. So the question becomes, what kind of event could produce all of this? There are 2 leading possibilities. First, a large body was captured by Earth's gravity and disintegrated, broken apart by tidal forces, its fragments flung outward by gravitational interactions with the Moon. This mechanism is well established. We have observed it with comet Shoemaker-Levy 9 at Jupiter. The second possibility, and this is the more dramatic claim, a planet was destroyed somewhere between Mars and Jupiter. This is the Phaeton hypothesis, debated since the early 1800s, when astronomers first noticed the asteroid belt occupies a suspiciously empty orbital slot. The debris from such an explosion would radiate outward, and fragments that lost velocity would fall inward toward the Sun, becoming comets. The Phaeton hypothesis has serious scientific roots. It was first proposed by Heinrich Olbers in 1802, the astronomer who discovered asteroids Pallas and Vesta. He noticed the asteroid belt sits exactly where Bode's law predicted a planet should exist. The idea that these fragments are the remains of a destroyed world has been debated in peer-reviewed literature for over 2 centuries. Here is what Keplerian mechanics predicts. If a planet explodes, fragments receive impulses in every direction. Those that decelerate relative to the planet's orbital speed fall inward toward the Sun. Their new orbits become elongated ellipses, and the closest point of each new orbit, the perihelion, clusters near the Sun. This is not speculation. This is how orbital mechanics works, the same physics NASA uses to navigate spacecraft. Now, what would the consequences look like for every planet in the inner solar system? The math predicts a gradient. Mercury, closest to the Sun, would intercept the most fragments at the highest speeds. Venus gets hit less but still heavily, Earth less still, Mars barely at all, and this is consistent with what planetary science observes. Mercury is a dense metallic core with almost no crust, Venus was catastrophically resurfaced, and Mars bears massive impact scars. One explosion, one dead planet, and it potentially cascades through the entire inner solar system. Mars is scarred, Earth is rocked but partially shielded by the Moon, Venus is devastated, Mercury is stripped to its core, and the leftover debris, the fragments too small to destroy planets, become Mets. The chain reaction model has testable predictions. Mercury stripped to its iron core by repeated bombardment. Venus catastrophically resurfaced with pole-to-pole furrows consistent with low-velocity impacts from nearby rather than deep space. Mars, bearing the Hellas Basin and Vias Marineris, scars consistent with massive but glancing impacts. Each observation aligns with what the model predicts. And those comets, Biela, Tuttle, Wirtanen, Hartley, all of them, they keep coming back on a schedule, a predictable, calculable schedule. And every time they come back, the historical record shows something happens on Earth. Now, I need to address the data reliability issue, because this investigation is only as strong as its sources. I tried to push the orbital calculations further back than 1600, and I hit a limitation. NASA's JPL Horizon system does not compute orbits before the year 1600 for most small bodies. The stated reason is that orbital uncertainties compound over centuries, making earlier calculations unreliable. That is a reasonable technical explanation. Gravitational perturbations from Jupiter and other planets accumulate, and small measurement errors grow exponentially over time. But it also means that tracing these comets to their common origin point, if it exists before 1600, is exactly the kind of investigation that current tools cannot support. The question remains open. If the original catastrophic event happened before 1600, then the computational limitation prevents tracing the comets back to their common origin. That may be a coincidence of accumulated orbital uncertainty, or it may be the single biggest obstacle to resolving this investigation. The data we need most is the data that is hardest to obtain. There is also a question about the sources behind the historical data, and it is worth being transparent about. Nearly all historical orbital data on comets available through public databases traces back to a relatively small number of calculators, including a Japanese astronomer named Kazuo Kinoshita. When I compared some of Kinoshita's published data with NASA's own calculator, I found discrepancies. The position of Comet Biela on key dates showed significant differences between sources. These discrepancies could reflect different orbital models, different gravitational assumptions, or different epochs of calculation. They do not necessarily indicate error, but they do mean that anyone conducting this kind of historical investigation needs to be aware that the numbers can vary significantly depending on the source. I want to be clear about my approach. This is an investigation, not a verdict. I am showing you what the orbital data suggests when you examine it independently, and the patterns it reveals are, at minimum, worth serious consideration. Now let me show you the single most compelling piece of visual evidence. I plotted all 18 comet orbits simultaneously using NASA's tool as they appear on a single date. Then I compared it to a computer simulation of what a planetary explosion debris pattern would look like. The visual similarity is remarkable. Every orbit radiates outward from the same region of space. They fan out like shrapnel frozen in time. And remember, these orbits periodically return to their point of origin. That is how orbital mechanics works. It is one of the most fundamental laws of celestial motion. Everything that leaves a point on an elliptical orbit comes back to that point. The debris from whatever created these comets passes through the inner solar system on a recurring schedule. Look at the pattern. Every orbit radiates outward from the same region of space. They fan out like shrapnel frozen in time. This is not what random comets drifting in from the outer solar system would look like. This is what the aftermath of a single violent event looks like, preserved in orbital mechanics for centuries. Now fast forward to 1918. The same comet debris, Biela's disintegrating remains, returns to Earth's neighborhood. By now the comet itself is gone, fully dissolved into a cloud of fine particulate matter, gas, and organic compounds. No visible fireballs this time, just dust settling through the atmosphere, globally. Hoyle and Wickramasinghe calculated that cometary dust entering Earth's upper atmosphere descends at approximately 30 meters per day in the stratosphere. Published in their peer-reviewed work through the Royal Astronomical Society, this model predicts that it takes weeks to months to reach ground level, arriving everywhere on the hemisphere at roughly the same time. This matches the anomalous 1918 spread pattern. Consider the human cost, and then consider the pattern behind it. The Spanish flu killed between 50 and 100 million people. It appeared in isolated locations with no human contact: military bases in Kansas, villages in Alaska, ships at sea for weeks. It hit in two waves, a mild spring wave and a catastrophically lethal autumn wave. Hoyle noted this matches two passes through the same debris field 6 months apart. And there is a broader historical correlation. The epidemic of typhus in 1812, the plague of the 1720s, the epidemics of the early 1600s, each lines up with a mass comet return in this dataset. Our ancestors connected comets with plague for thousands of years. Modern science dismissed it as superstition, but Hoyle's hypothesis suggests they may have been observing a real correlation. Consider Napoleon's retreat from Moscow in this context. He arrived in autumn 1812 without winter provisions, suggesting he did not expect extreme cold. If cometary dust entered the atmosphere and reduced sunlight, the sudden temperature drop would have been as unexpected to Napoleon as to anyone. The retreat may have been driven not by poor planning alone, but by an atmospheric event no general could have predicted. The pattern across the dataset is consistent. E54, 6 comets, historical upheaval. 1608, 7 comets. 1619, 9, Biela's closest approach, calendar reset. 1724, 8 comets, plague in Europe. 1812 to 1818, 14 comets, fires, climate disruption. 1918 Spanish flu. The correlation does not prove causation, but it warrants further investigation. You might ask, what about recent years? 3 of the 18 comets passed in 2017, 1 in 2016, 3 more in 2018. But here is the encouraging detail. These comets have been shrinking for centuries. Each pass they lose mass. The debris diminishes with every cycle. But diminished does not mean gone. Comet Biela disintegrated completely, yet its debris field produced meteor storms for decades afterward. The fragments get smaller but more numerous. They spread across a wider swath of space. The visible fireballs fade, but according to Hoyle's model, the microscopic dust and organic compounds may actually increase as the material disperses. This raises a provocative question. If cometary debris can carry biological agents, as Hoyle and Wickramasinghe argued with extensive published research, and if the debris returns on a calculable schedule, then certain pandemic events might not be entirely random. They might follow a pattern that is, in principle, predictable. We laugh at our ancestors for fearing comets. We call it superstition. But perhaps they were observing something real, a correlation between cometary appearances and disease outbreaks. Not because of magic, because of physics and biology operating on a scale we are only beginning to understand. Let me summarize what the orbital data shows. 18 comets with perihelions near Earth. 14 with orbits consistent with being ejected from Earth's vicinity. All 18 converge to common passage windows between October and February. Their return clusters correlate with major historical events from the 16th to the 20th century. The math says yes, these comets appear to share a common origin. The proposed mechanism is clear. A catastrophic event, possibly a planetary explosion, possibly a large body disintegrating near Earth, launched debris into solar orbits. That debris returns periodically, bringing atmospheric contamination and potentially biological agents. Each return is weaker than the last, but the pattern in the data is hard to dismiss. I started this investigation by asking a simple question. Do all comets share the same origin? The textbooks say the Oort Cloud and Kuiper belt, distant, and for historical comets, difficult to verify. But when I traced 18 orbits backward through time using established tools, they did not scatter randomly into the outer solar system, they converged. Here, near Earth's orbit. Here, the debris is still out there. It is smaller now, weaker with each return. But it has not stopped, and because we can calculate the orbits, we can predict when the next cluster will arrive. The question is whether the scientific community will investigate this pattern seriously, or whether it will remain an overlooked anomaly in the orbital data. 1699, 1812, 1918. 3 dates, 1 comet, 1 pattern, and behind them possibly 1 destroyed world whose debris has been shaping human history for centuries. The math says yes, the orbits converge, and